Hello there, really quickly, I'm going to solve this quintic polynomial by using factoring by grouping. So I notice out of here I get an x cubed term that leaves me with x squared minus 1. Now there is no greatest common factor here, but that means I can put a plus 1 here and I still get x squared minus 1, which is great because now I've got my common factor of x squared minus 1 to come out, and the remainder is x cubed plus 1 equals 0. Now what I have here is a sum of cubes and difference of squares. So let's go ahead and factor those. This is the best approach in situations like these. Factor as much as possible. So here we have our difference of squares. Here we have our sum of cubes. We get x equals 1, x equals negative 1 from both of these solutions. So that has a multiplicity of 2. And then let's go ahead and use the quadratic formula here. And those all are solutions. Hello there, I'm going to solve this quintic polynomial using factoring by grouping. Now you can go ahead and use 2 terms if you want, or you can factor by 3 terms. I'm going to go ahead and do by 3 terms. So these first 3 terms have an x cubed in common. So that's x cubed times the quantity x squared plus x plus 1. And then from these next terms right here, there's nothing in common, so we'll write that as a plus 1 x squared plus x plus 1 equals 0. So when I factor my common factor of x squared plus x plus 1, I get x squared plus x plus 1 times the quantity x cubed plus 1. Now this is really interesting because we have a sum of cubes here. So we got x squared plus x plus 1 times x plus 1 times x squared minus x plus 1 equals 0. Now this will give us a solution of x equals negative 1. Notice we've got 2 very similar looking polynomials. So really quickly, I'll go ahead and use quadratic formula on this first one. So that's negative 1 plus or minus the square root of 1 squared minus 4 times 1 all over 2. That would equal negative 1 plus or minus I root 3 over 2. Now, because the only difference between this polynomial and this polynomial is this minus sign right here, that will also give us the positive of that, giving us a nice way to simplify our final answer. And hello there, I'm going to solve this polynomial that looks like a quadratic, except there's a 4 there and a 2 there. Well, I can still use my factoring technique, so I'm going to set up diamond math and put negative 4 up top, 3 down bottom. My factors are 4 and negative 1, and when I factor this out, I'm going to write x squared plus 4 instead of x plus 4, and I'm going to write x squared minus 1 instead of x minus 1, because now x squared times x squared gives me x to the 4th. Now we have a sum of squares, so I'll go ahead and use the complex way of factoring that out. So that'd be x plus 2i and x minus 2i, and then I've got a difference of squares here, so that's x minus 1 times x plus 1 equals 0. So here are all 4 of my factors. I'll go ahead and set each of these equal to 0 and solve them. I get x equals plus or minus 2i and plus or minus 1 as my solution. Hello there. I'm really quickly going to solve this polynomial that looks like a quadratic, except there's a 6 there and a 3 there. But because of this, I can still set up diamond math, put 9 up top, 6 down the bottom, and my factors are 3 and 3. So factored form would be x cubed plus 3 times the quantity x cubed plus 3 equals 0. Now, this effectively means I have a solution set which each solution will have a multiplicity of 2. So I only need to solve one of these once. I'm going to use sum of cubes, so that would be we get x equals negative cube root of 3 from this first one. Let's go ahead and set up the other one in quadratic formula. That'd be negative. We get a cube root of 3 here, plus or minus. We'll get a funny looking solution, but a solution nonetheless. And remember, these all have multiplicity of 2. Hello there. Don't let appearances fool you. This is a difference of squares we're dealing with. So the factorization would be x squared minus 1 times x squared plus 1 equals 0. Now we still have a difference of squares here. That'd be x minus 1 times x plus 1. And we have a sum of squares here. We can use our complex factorization. That'd be x minus I times x plus I equal to 0, and then set each of these equal to 0. X minus 1 equals 0. That'd give us x equals 1. X plus 1 equal to 0. That'd be x equal to negative 1. X minus I equal to 0 would give us x equals I. And then x plus I equal to 0 would give us x equals negative I, and those are all our solutions for this polynomial. Hello, don't let appearances fool you. This is a sum of squares. The only problem is if we use our complex factorization of sum of squares, I get x squared plus I and x squared minus I. Not a problem so far, but let's go ahead and solve these algebraically. X minus I equals 0. That means x squared equals I. And then when we square root, what is the square root of I? Well, let's go ahead and use our polar form. We've got I would be equal to e to the natural log of I, and we're square rooting this, so that would be times 1/2 here. Now the natural log of I would give us pi over 2I. That would give us e to the pi over 4I. Now with a modulus of 1 and an argument of pi over 4, this would be equal to root 2 over 2 plus root 2 over 2I. So the square root of I would be this thing right here. Now remember, we need the plus and minus of that, and we're also going to get effectively the conjugates from here. So our final solution set is x equals root 2 over 2 plus or minus root 2 over 2I, and then x equals negative root 2 over 2 plus or minus root 2 over 2I. And that is the final answer. Is it a difference of cubes or is it a difference of squares? Well, let's try both. I'm going to start with a difference of squares. That means our factorization would be x cubed minus 8 and x cubed plus 8. Now, our factorization using difference of squares happens to give us a sum of cubes and a difference of cubes. So we're going to write that out as x minus 2 times the quantity x squared plus 2x plus 4. And then for our other one, it'll be x plus 2 times the x squared minus 2x plus 4 is all equal to 0. So we can see that x equals 2 and negative 2 are solutions. Now, using quadratic formula on, say, this right here, we get and notice the only difference between these last two polynomials is that minus right here. So that means our last set of solutions is x equals a positive 1 plus or minus I root 3. And we are okay. Let's go ahead and use difference of cubes this time. That means we're going to have to set up a, that'd be x squared, and b would be equal to 4. So x squared minus 4 times the quantity x to the 4th plus 4x squared plus 16 equals 0. Now from observation, this really is just a difference of squares, so that's going to give us x equals plus or minus 2. Let's really quickly run through the quadratic formula. But remember, this is x squared, so we would need to take one more square root. So we get x is equal to plus or minus the square root of negative 2 plus or minus 2I root 3. Now, if you go ahead and do some algebraic manipulation and simplify this, you'll find that these two, or rather 4 solutions, are the exact same as what we had in the other video, which gives us all the same answers, and we're done.